Yeah, DC'd there. Might be. Am I back? I hope so. I hope we're back. Yeah, I've had issues today. All right, Jessica, you have a great one, okay? No problem. Catch up on stuff. We'll catch up again soon, okay? All right. Hey, thanks. Hey, Chase. We're gonna cover sections 6.1 and 6.2 today. Okay, cool. All right, we'll wait a couple more minutes here, and we'll have people come on in, hopefully. Wait for a few more people to come on in here today, so should make it a bit easier for you. Hey, should be all right. Alrighty. Really quick here for everyone who's here already. I just want to point out one very important thing for everyone. If you do have your calculator here, your graphing calculator, we're going to be using that fairly heavily here today. So the graphing calculator is going to be your best friend here today. So kind of try and follow along here with the calculator stuff. So if you don't have that out, please go ahead and take that out right now, as we're going to talk about how to use the calculator in the graphing calculator in this circumstance here. I'll be using the TI-84, or again, if you have an 84, 83, I'll be using that one there. I don't know much about the Inspire and whatnot, so I'm kind of out of luck on that one. I'm not sure about how Inspire works because it's just a super robust calculator. This has a lot of different submenus and stuff. So you'll kind of have to figure that out on your own if you do have that. But the the spirit is just the same, I suppose. So yeah, we'll talk about how to get that once we get going here. So I just wanted to point that out so that way nobody's caught unawares about what's going down. So. So I'll wait for just another minute or so, and then we'll get going. We'll get going like the fools that we are. All right. I don't even know what that means, but sure. Okay, that's cool. I totally understand that. like I said, what we'll be doing here is just at least setting it up via the calculator. So I'll write down some steps here on the on the on this thing here using the 8384. But yeah, we'll go ahead and see how that works here. So it shouldn't be, like I said, it's not going to be too hard. So, you know, is that at elgin.edu? I think that's elgin.edu. Yeah. All right, there we go. Yeah, I won't post the link there, so made sure got got that in for you. There you go. All right, let's get going here. All right. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, we are going to continue moving forward here, and today we're going to start with Chapter 6, okay? We're going to be doing the first couple of sections here with Chapter 6, and uh, today, what we're going to be talking about is we're going to be talking about all in Chapter 6, talking about matrices, okay? So a lot of the things that we're going to be discussing here are going to revolve around solving system of equations here, and then representing in matrices, and then solving for those particular matrices. Okay, so let's discuss about how to do that here in this particular instance, and we'll see what we're working with. Okay, so this is from the handout from last time, okay? So we did question 1 there, which was talking about nonlinear systems of inequalities and linear systems of inequalities. Today, we're going to be talking about matrices here, the start of section 6.1. So let's go ahead and answer the second question here, and that asks, what is a matrix? Okay, so let's talk about what a matrix is on the basic level, okay? So a matrix is a representation of a system of linear equations. Okay, so it will be a representation of a system of linear equations, and we're going to go ahead and describe how we can represent our linear equations here. Now, in this particular circumstance, like we did in the last chapter here, we did like 2 equations and 2 variables. Whether that would be linear or nonlinear, we just had like x and y, and then, we solve for x and y. If we had multiple answers, we had multiple answers, or we had, one ordered pair as our answer. Okay, fine. You have no solutions, infinite solutions, whatever the case may be. In this particular case, we're going to go down that same path here, only we're looking at maybe not just x and y. Maybe this time we can go with even more variables than x and y. Maybe we could go with x, y, and z. Okay, so if we go with x, y, and z, or heck, even a 4th variable if we wanted to, we can solve those system of equations, maybe not by the substitution or, again, elimination methods, as they may take a little bit of time, but again, doing it via these matrices that we see here. Now let's go ahead and at least type out an example here about a system of linear equations. This time though, the key difference here in this particular case is that we're going to have a system of linear equations in 3 variables. I'll get that later. All right, so let's go ahead and put down a system of linear equations in 3 variables first. So that, all right. So I'm going to go ahead and take there you are. Okay. So let me try. All right. Okay. Got 2x minus y plus z equals 5. And minus x plus 2y plus 2z. Okay. So here are 3 equations. In this case, we have 3 equations and 3 variables. Okay, so 3 equations and 3 variables. Now, this is a perfect example of, substitution elimination is going to be, well, it's going to be a pain, all right? Maybe too many moving parts. So matrices basically shorten down this kind of, kind of the many moving parts of substitution elimination, and put it into an easier point of view. Now, what is the one thing about matrices that we have to look at here? Well, let's take a good look at how matrices are going to basically look like. So matrices, we're going to have a column here. Now, let me go ahead. We're going to have columns and we're going to have rows, okay? So I'm just going to go ahead and point this out here on the Word document. So we're going to have each column represents a variable or answer, okay? And we'll talk about how we set that up in just a second. All right. And each row represents an equation. Okay. So the way it goes, it kind of goes like this. Let's go with, wait, do I want to show this off? Okay, let me do that, and then I'll put that in the math lab, in the math type thing. So get my paint tool out here. All right. So the way I'm going to do this is we're going to have a matrix here. And as you can see here, let's go back to our example here for just a moment on math type. And we'll see exactly what this looks like. All right, so here's our example here. Now, in order for us to make this matrix, we're going to have a few columns here. We're going to have an X column, we'll have a Y column, and we'll have a Z column here. But I'm going to draw a little bit of a line here. And this is going to be our equals column here on the right-hand side. Okay? Number 1 was what we did last time, Chase. That was the linear and nonlinear inequalities. That was from chapter 5. So that's why we're not doing number 1. We did that last class. Okay. So here we have, again, we want to put in the coefficients for each x variable into this first column, which is, again, coefficients is the fancy number for, again, the fancy thing for like the number in front of x, or again, the number in front of the variables. So in this case here, if I have x plus y minus z equals minus 2, I would put 1 here for x, 1 here for y, minus 1 for z, and minus 2 would go over here. This is your answer on this last column. Okay? What would the next row be? What numbers should I put in for the next row? Two minus 1 and 1. And what else, Gerda? We're missing one more number there. What goes over here to the right? All right, 5. Good. Okay, so we can't forget about the answer part there. That's why I kind of write this line here. It reminds ourselves that we do have to acknowledge these numbers here all the way to the right as well. And how about the last row there? What should we put for that? Okay, minus 2, minus 1, sorry, minus 1, 2, 2, and 1. Perfect. Nice job, Gerda. That's correct. All right, so let's see what we have in front of us here. This is, in effect, our matrix that we're going to be able to enter in to our calculator here once we need to set this up and solve for x, y, and z appropriately. Now, let's talk about one other thing here in relation to this before we move forward. What's the goal that we're looking for here? Well, we are essentially still doing the same thing we did in the last chapter. We're still trying to find a solution for x, y, and z. That part is still true. Now, our goal here, in a sense, after we do our processes, is we want this matrix here to somehow magically change to a matrix that looks like this. So this is what I want the matrix to look like after everything is said and done. So A, B, and C here can be any number that you want, okay? So A, B, and C are just random numbers, all right? So let me go ahead and point that out here at the very least. A, B, and C are random numbers. Okay, I don't know what they are, but whatever. Okay. Okay. Now I'm going to go ahead and type this matrix out in here, and I want to showcase exactly what we need to be looking for. Now I want you to see one thing right away. We have 3 rows and 4 columns. Okay, so one thing that I do want to point out here, and let me go back to the Word document here, is anytime we define a matrix, when we define a matrix, and this will be important for what we'll do on the calculator here, when we want to defining a matrix, we always want to go by rows. Where's it? Rows by columns. So it goes like 3 rows and 4 columns, for example, would be this matrix that we see. This matrix that we see here would be 3 rows and 4 columns, so a 3 by 4 matrix. So if I say, for example here, like I could make up a matrix here on this, so I say 3 rows and 4 columns. And then I can enter in my numbers here exactly as I see over there. So this is just to kind of showcase, you know, what that looks like with the full matrix kind of put in. Okay. Typically, these matrices don't have this line here, but I put the line here to remind myself what it's equal to for each equation. So if it helps, if it helps you when you write it out, write it with this line here. You cut the difference off here. Okay. Now, next. Now that we have a good idea about what this matrix is supposed to look like, let's talk about how we can go ahead and take care of the next question here on the handout. Alrighty. Okay. Now for the purposes of this example here, we're going to go ahead and use our calculator for this part. Normally, I would do this lecture and it would take quite a long time to do. But I want to actually, I just want to expedite this process here, because if I lectured about how to do the Gauss-Jordan method, number one, you'd probably hate my guts as I ramble on for at least an hour and a half. And number two, well, I mean, honestly speaking, we just kind of want to get this stuff done so we can move on to the next stuff as quickly as possible. So, we just want to talk about the calculator process here in this case. All right. So really quick here so I can give you guys an appropriate amount of time. I know I said it earlier in the class here, but if you have your TI-8384 calculator, whatever calculator that you use, or Inspire, whatever, go ahead and take your calculator out. Once you have your calculator, your graphing calculator next to you, and yes, this will require a graphing calculator, um, uh, then go ahead and say like yes in the chat, so that way I know that you're prepared and ready to go. Okay, morning's ready. Anybody else who's ready? Remember to type yes in the chat if you're ready. Okay, so I got Gurden drivers. All right, Fidel. All right, Planet. Yeah, we're gonna be working with some stuff here. Yes. Anna. We got to go through the process here first. All right. So I'm gonna go ahead and get started here, unless there are any more people who need to get their calculators ready. Okay. All right. Now that people are ready here, let's go ahead and talk about the process here, about how to solve for a matrix, and then be able to interpret that into our final result. Okay, so I'm going to write down some of the instructions on here as we go along. All right, so we'll go ahead and do that right now. All right. So the first thing that we have to do is go to the matrix submenu here. Now, to get to the matrix submenu here, again, preface it by saying I'm using the TI-84 for this. We're going to go ahead and hit the second key, and then we're going to go ahead and hit the x to the -1 key, which we'll hereby call the matrix key. When you hit second and the x to the -1 key, so we hit second and x to the -1, that will take us to our matrix submenu, just like so. Now, what you should see at the top of the screen is you should see three things. You should see names, math, and edit. Those are the three things you should see at the top of the screen. Now, what I would like you to do is you're going to, again, scroll over to edit and hit enter. Okay, so just scroll over to edit and hit enter. Now, enter will basically get you to matrix A. That's that first one you see there. It says A. That's going to be your first matrix. We call that matrix A. Now, it just depends how old your calculator is. You may see, maybe you had a matrix there from before, I don't know. Even if you don't, you may just see one number put in there. Now, at the very top of the screen, you will see two numbers that you can plug in. They'll say like 1 and 1 up there, probably on the top of the screen. Those are going to reflect your rows by columns. We talked about that earlier. How many rows and how many columns here? All right, so we want to enter in the rows by columns, okay, in the very top. Okay, so we're going to go ahead and hit 3, hit enter, and hit 4 and enter, and then suddenly you should see more entries pop up on the matrix below. So you should see maybe some columns and things like zeros or whatever pop up on your calculator. I want to be sure here. Is everybody, are there any questions so far? Everybody kind of following along here? I want to be sure that everybody's got that before we move forward. Any questions so far? No questions? Okay. All right, so I'm gonna move on. If anybody's stuck, you let me know, and then I'll stop. Okay, and then just ask. Okay. That's why I'm going slow here. So, because I can't see your calculators there. So, all right. Well, let me move forward then. Okay. Again, stop me whenever. All right. Stop me whenever if if you're having a tough time. All right. So what we're going to do next is we're going to enter in all the necessary numbers in the matrix. Okay. So that's what we're going to do next. We're going to enter. So we have the matrix we want up here, as you can see on the screen. So we're going to just go ahead. It goes left to right here on your calculator. So we'll go ahead and enter in the numbers here for every row and column. 2 minus 1, 1, 5, and negative 1, 2, 2, and 1. Okay. Okay. Now this is very important. This next step is incredibly important because of the way the calculator is kind of set up. So one of the most important things here is to make sure you don't put any bad entries into the matrix. And the calculator is pretty particular about it just because of the way it's kind of set up. So what I would like you to do next is, once you have all the numbers entered in, I want you to go ahead and hit the second key once again, and then hit the mode key to quit, which is right next to it. So you're going to quit. This will quit to the main screen. So there may not be anything on the main screen, but it's one of those habits here on the calculator that is actually very important, especially for matrices. And that's because if you decide to go to another submenu and then call another function, it'll accidentally put that function in place of that number, and then it'll tell you like syntax error or something like that, and then you're going to have a lot of problems. So one of the things that I stress on is to make sure you don't have any bad button presses through the process. Just go ahead and hit second and mode to quit to the main screen once we're done with that part there. Okay. Just good habits for the calculator overall. Again, the calculator is very finicky in particular, so we're going to acquiesce to its demands since it's going to do the work for us. Okay, so let's talk about what we're going to do next. Okay, once again, we're going to hit the second key. We're going to hit the second key, and then again here, we're going to go to the x to the minus 1 key, so the matrix key here. Okay, so we hit second and x to the minus 1 key. Now, what you should see at the top once again is our same three menus we had when we first did this. We have names, math, and edit. This time, what I would like you to do is go over to math. Okay, go over to the math submenu. And there is a particular math submenu option that we're going to do from this long list. We want to specifically pick option B. So hover over option B, which says RREF, and it has a parenthesis next to it. and hit enter. Okay. So on your main screen here, you should see RREF with a left parenthesis. That's it. That's all you should really see on your main screen so far. Okay. All right. Then, yes, that is correct. So RREF represents row reduced echelon form. That is correct. So if you've heard of it before, this is exactly what the Gauss-Jordan method exactly does for us. That is correct. So it's a nice little shortcut to get us there. So you probably have done this in the past. Nothing going on in terms of how it's done. Okay. Okay. Next, what I would like you to do here is once we have that, we're going to hit the second key again. So second key, x to the -1 key. We're going to go back to our matrix menu here one more time. Okay. Go to our matrix menu here. And now, as you see, we see the names, math, and edit. This time, the cursor where it starts at is underneath the name submenu. And you can see matrix A is that same 3x4 matrix that we had entered in earlier. So I want you to go ahead and hit enter on matrix A underneath names. All right. And we'll go ahead and enter there. All right, and then all we have to do is close the parentheses and hit enter. And a matrix on your calculator should pop up. So let's take a look at the subsequent matrix that we should get here. And let's make sure that we all got the same matrix here. So I'm going to post it up here. And I'll copy paste this. So go ahead and put that down. Bam. All right. Okay, so the matrix that we should get here is this. So this is the matrix that you should have gotten for your final result for this answer here. And remember, we did talk about this. This is the goal that we wanted here. We wanted 1, 0, 0. We wanted 0, 1, 0. We wanted 0, 0, 1. And we got some numbers here on the right-hand side. Okay, so this is exactly what we're after here. Now, what exactly does this mean? That's really the thing. But before I go ahead and talk about what this means here, let me go ahead and get a poll here. Did everybody get this? Again, just type yes in the chat if you got this exact matrix through this process. I want to go ahead and have people just type out yes. I just want to be on the safe side that you got this here. Okay. So you got 7/3 and 2/3 and 1. Okay. Okay, Chase, you're going to have to check your numbers there one more time. So you should have 1, -1, and 2 there. So make sure that you recheck your numbers there, okay? Because that's what you should get. You should have 1, -1, and 2 here respectively. So be sure you entered in that matrix there appropriately. Again, maybe you missed a sign somewhere. So this is your original matrix up here. Check that one more time. Okay, planet and drivers and morning. Gerda, did you get the answer there? Okay. So after following the steps there, did you get the... So no. Well, could you give it a try, please? And I want to make sure that everybody gets the answer here. That's very important. Okay? Like I said, there's a lot of steps here, so I want to be double extra sure everybody who's here on the stream, or again listening, and just make sure that you got this answer here. Okay? Okay, cool. Great. All right. So looks like it's Lucas here, so he'll get it or not, I don't know. Does the random numbers matter? Yes, they do. Quite significantly, yes. The numbers here on the right-hand side do have a meaning. Yes. So these numbers here on the right-hand side should be 1, -1, and 2, respectively, Chase. So let's talk about what these numbers mean, now that we've boiled it down to that. Okay, now this is the goal that we had in mind here, okay? After we reduce this down. Now, what exactly does that mean in the context of this problem? Again, remember that this was our x column here. Oops, you know what? I'll put that underneath. All right, so this was our x column here. This is our y column here. This was our z column here. And this was our answer column here. If we break that down and split that up, that means that x here, if we just take a look at that here, is equal to a. Y here will equal to that b answer here. And z will be equal to that c answer here. So in a sense, basically what we see here, well, make sure you replicate it, make sure you put in the right numbers there, okay? Again, what you could have done is, you could have just accidentally hit a wrong number in the matrix, so be sure you check all your numbers there, okay? Okay, so our answer here, let's talk about what our final answer is going to be here, based on what we see. So based on what we see here is that x here is going to equal 1, because that's from the first row, we see x is equal to 1. We see y is equal to -1. And z here is going to equal 2. So these are this is our ordered set of x, y, and z that will satisfy those 3 equations and 3 variables. Again, using row reduced echelon form to get down to our final answer. So if they do ask you on the homework here, they may ask you to write it like this. They may ask you to write it like 1, comma, minus 1. Why do you go to 11 point? Never asked for that. 16. Okay. So it may ask you for like, again, 1, comma, minus 1, comma 2. Okay, so something akin to that is what they'll ask you there on the homework. Okay. Any questions about that so far? No? Okay. Let's go ahead and try another here. Okay, we'll try another system of equations, all right? And hopefully we'll get that to work out. Let's take a look here. All right, so I'm going to write down a new system of equations here. I'll write down a new matrix to boot. So, all right. Write this down. All right, let's try this one here. Okay. All right. So here we have, again, x minus 3z equals minus 2. 2x plus 2y plus z equals 4. And 3x plus y minus 2z is equal to 5. Okay. So can anybody tell me here? Let's put this matrix together here first before we put it in the calculator. So what numbers should I put here in the first row? Anybody tell me here, what numbers should I put here in the matrix in the first row? What numbers should I put in the first row of the matrix? 1, 0, and minus 3? Okay, good. Just those, though. Just 1, 0, and minus 3? That's it? All right, minus 2. You can't forget about the answer. Yeah, you can't forget about that answer. That answer also has to be included. All right, if you leave that off, then you're not going to find anything that's going to be worthwhile. Okay, so you can't forget about that answer. It's got to be on the right-hand side there. You must remember, yes. Absolutely. I demand satisfaction, darn it. I respect my authority. All right. Yep. All right. Now, one other thing that I guess I should point out here, most definitely, uh, outside of just being a very harsh dictator right now, is come on, what? Okay, there we go. That's better. All right. So one thing I do want to talk about here is an important note here. So note for this here. Um, even if it's not represented, you know, we have x minus 3z is equal to minus 2. Even if you don't see a y, that still needs to be represented. So all coefficients for all variables must be represented. So again, what you're going to put here is put 0 in places where you are missing variables. Okay. So that's one of those things that you should not forget here when it comes to building your matrix there. Okay. So want to make a note of that. That way, again, you'll know to make that adjustment. Okay, what about the second row here? What's the second row? What's the second row we see here? All right, 2, 2, 1, and 4. Good. That's correct. Very nice. And how about the last row here? What's the last row? All right, good. 3, 1, -2, and 5 is going to be our last row, just like so. Okay. All right, so that's going to be our next rodeo here. Okay. Now we have our matrix here. Let's see if we can reduce this down appropriately. All right. Now this time though, I'm not going to help. All right. I will get an answer here for sure, but I'm going to have you guys find how to do that here. So I have the matrix up here. That way you can reference, of course, the numbers that we'll need. But I'm going to leave the instructions up here, okay, for this process here. So let's go ahead and give it a try. Put that in the middle of the screen there so my face doesn't hide it. Okay, and then let's see what we get for X, Y, and Z appropriately. All right. Let's give it a go. The instructions are right there on the Word document. Once you have an answer there for X, Y, and Z, go ahead and post that in the chat. Okay. All right, so Planet got that. Anybody else? Got the same? Okay. Anybody else get the same as Planet? I'll wait for others to kind of tell me. Again, I want to be sure that you guys can get through this process without too much trouble. That's important. I can wait. All right, so your calculator got the same. Anybody else get the same answer? X equals 4, y equals minus 3, and z equals 2? Go ahead and say if you got the same answer or not. Want to be sure if everybody got that there. So hey Lee, how are you, my dude? Hey guys. It is it's the Lord Magistrate himself. My man, Mr. Lord Magistrate. We're covering matrices here today. Hey guys. Hey Jeremy, how are you, my friend? How are you? How goes the court in session? I'm playing FIFA. You know, I'm gonna try some FM21, guys. I'm just gonna let you know, my first time trying FM21. I'm very new, so I'm gonna be trying streaming some FM21 if you want to watch a newbie play on maybe some weekends. So we'll see how it goes. Oh, Lee, thanks for the sub, dude. It's so nice. Oh man, don't worry, I won't be streaming FM21 here today, but I'll be doing it on another day when I don't have classes. No, I totally understand, Jeremy. Totally understand. Get some rest, my friend. You gonna solve this equation? That's fine. It's all good. Steven, I'm doing very well, my friend. Doing very, very well. Having a ball. Oh my gosh, it's Lee. Lee, buddy. Lee. Lee, a legend. Like Chase and Planet, Morning and Jan and Civil Engineers. Jeez Louise. Holy moly. Oh, I don't deserve that, man. I'm just an old geese. I don't need that. Oh, all right, Lee. Holy smokes, guys! Oh man, I don't deserve the subs. I'm just a regular dude teaching mathematics. Mathematiques. Man, that's very generous of you, Mr. Lord Magistrate himself. You you have a very kind soul. A very kind soul indeed. Holy cow! Thank you so much, man. That's very super kind. Like I said, much love, much love coming from over here. Got a hey, there you go, coming in with another one viewer. Hey, I respect that, man. Respect. Thank you for hosting. Appreciate you. Bless you, Lee, man. That's really awesome. Yeah, I told you I'm gonna come over to England and I'm gonna watch a match. You know, better believe it. It's only then I'm gonna get my emote. So that's the only time I'm gonna actually have my emote there. Why is I'm gonna tell LP I don't want to send him my picture just yet. So it's got to be done in person. It's got to be done in person. If it's not done in person, then it ain't worth my time. You know, because I'm just old-fashioned that way. Okay. I'm super old-fashioned that way. You know, but it just makes like the trip worth it even more. Get the maths done. Yes. Mercy. Mercy, mercy, mercy. You know, Lee, you know what, Lee, you get mod status, my dude. Here you go. You get mod privileges, Lee, for just being you. You're the best, dude. Appreciate you, buddy. I always give mod status to people who I know I can trust, and I can always trust the Lord Magistrate himself. So, oh yeah, that reminds me. Now you ban me from class. That reminds me, I got to mod Jeremy too. Here you go, buddy. You get my mods as well. So all right. This is gonna be. You're going to bed. Speak to you tomorrow. Thank you, Lee. You're a legend yourself, my friend. Never stop, never stop winning, my friend. Have a great night, Lee. Mr. Lord Magistrate himself, everybody, Lee Herseth. All right. Appreciate you, bruv. Rest up, rest well, everybody. Okay, so let's take a look here at what the answer is going to be, because I still got an answer to give for this matrix here. So hopefully you got the same answer that I did. So you should have gotten 4, -3, and 2. So this is what should appear on your calculator here. All right, so you should have gotten this answer right here for this matrix. All right, just like so. So let's take a good look here. All right. So again, what's our answer here? Again, the first column represents the x's, second y's, and the last one the z's. So again, x is equal to, when it's not, why is that so tiny? All right, not understanding. All right, one of these days. X equals 4, again, y equals -3, and z, or z, as you guys like to say, z equals 2. So we have, again, 4, comma, -3, comma, 2 would be our answer that we would have here for the answer to this matrix. All right. Are there any questions about that? I want to be sure that you guys got that. So go ahead and type in yes in the chat if you got this as your answer on your calculator here. So let's do that here. Type yes in the chat if you got this answer. Okay. I just want to be sure to be on the safe side that you guys got this answer here, so that way I know that the process here is going consistent. If you did not get this answer here, that's okay. I'll go ahead and reiterate and see where we went wrong. So that way I want to make sure that you match that answer there. Anybody else having issue or again did not get this answer? I just want to be on the safe side. So and we all got to be on the same page. So, you know, just being myself. Chase, Fidel, Planet, you guys good? Drivers, did you get it? Yes? Yes? Drivers? Drivers, okay, yeah? All right, good. Good, good. Chase? I might have missed your comment earlier. Did you get this? If you're there. Anna? If you guys are there. Yes, okay, good. Good, good, good. Morning? Morning got it? Okay, good. I just want to be double extra sure everybody got this process down, because we're going to use this process again in another couple of examples. So again, just keeping it consistent there, so that way we can do it without, again, any trouble here. So there you go. All right, good stuff. Okay, so that is in a sense section 6.1. We're going to move to section 6.2 here in just a second. But any questions on this section here, section 6.1? Like I said, normally this would be a very long lecture for 6.1, but considering it's COVID stuff, Hannah, hey, that's okay. That's okay, Chase. Just go ahead and refresh and hit F5. So you should be fine then. If your computer's lagging a little bit. So once you guys, any questions on 6.1? I hope, hopefully that process there makes it crystal clear. Jibs, you gonna shoot off to bed? Yeah, have a great rest of your night, okay? Jeremy, sleep well tonight, okay? I'll see you tomorrow, all right? Maybe I'll start the FM series after I'm done with my class tomorrow. So, got an extra class to do tomorrow, so very important. So I'll be on. Yeah, work, man. All right. You know, anybody here, you guys are always welcome to come here and ask and have a little fun, and we're just here to sit and chill and hopefully feel better. That's learning. Yes, learning is good. Okay, very good. Okay, so that is section 6.1 in a nutshell. All right, let's move on here to section 6.2. Let's bring up that handout right now. Bring that up right. It's on a separate handout, so I'm gonna bring that up. All righty. Yeah, we're not going to get to the other half here, but we're going to do section 6.2 here because it has a lot to do with what we just talked about. So we'll definitely discuss about that. And it's not too hard, but again, it will require the same steps as before. We're just going to be on the lookout for a couple things. So we want to be just a little bit careful, but don't have to be like super duper, hardcore about it. So, okay. Anyway, let's go ahead and take a look here at section 6.2. Let's look at question number 1 here. Question 1 says, what is a square matrix? Okay, now this question here by and large is not too hard, but it is something that we could see here later on, and it's something that we do look here at for certain reasons a little later on. But a square matrix basically is a matrix that has the same number of rows and columns. Now I do have to be a little bit extra clear about this part here. When I talk about the same number of rows and columns, I'm talking about I exclude the answer column. So basically when I talk about, so I guess I should say excluding if I'm going to be more precise. So whatever the answer column is, I'm actually going to take that off, and I'm just going to see how many equations with x, y, and z I actually have. So essentially I have say for example here, I have 3 equations, 3 variables like we did in our last section, then I'm going to have, again, that's going to be a square matrix. Again, 3 equations with 3 variables, sans the extra answer column that we normally put down in order to solve for x, y, and z. So uh, really, we're going to be looking at some cases where maybe we have a square matrix, like we have the same number of equations and the same number of variables, or we may end up looking at some equations here which definitely don't have that case. And we're going to be looking at 2 individual cases. Yes, exactly, Planet, just like the last example. That is correct. Okay, so that would be like a 3 by 3 case because, again, we had 3 equations and 3 variables. Okay, that's absolutely right. In our calculator, we put it as a 3 by 4, but that's only because we put the answer matrix there. That's where we actually acknowledge it. So I know that seems very confusing, but that's the way they define a square matrix, so we're going to have to run with that definition. Now, let's talk about what we're doing here in this particular section. Now, in this particular section, we're going to basically throw back to what we talked about here in the last section, in the last chapter, pardon me. In the last chapter, we talked about 2 equations, 2 variables, or the like, and we talked about either no solution or we talked about infinite solutions. And once again, for matrices, because we can still have that situation happen, well, that's what we're going to explore here. Okay, so let's take a look here at this first question here, number 2, in relation to that. It says, how do we find inconsistent systems in matrices? Well, first of all, let's define inconsistent. An inconsistent system is basically tantamount to no solutions. Okay, that's basically no solution. There's no way we're going to be able to find a solution for that particular matrix. Okay, well now comes the important question here. What exactly are we looking for here when we want to find a no solution case? Okay, so what we're going to do is we're going to do an example here, and I'm going to show you what you want to look for here specifically, so that way you can identify that there's no solution for that particular problem. All right, so let's do our example right now. All right, so I'm going to type out the 3 equations and 3 variables here for this particular problem. Okay, so let's do this one here. And okay. Okay, so here's our 3 equations, 3 variables. So this will be a square matrix, of course. Okay, so we have 2x minus 4y plus z is equal to 3. We have x minus 3y plus z is equal to 5. And 3x minus 7y plus 2z is equal to 12. Okay, first things first here, let's set up our matrix. Okay, so that's what we'll do here first. We're going to set up, in this case, a 3 by 4 matrix. Again, we are going to obviously include the answer column here because we need to go ahead and reduce it down like we did in the last couple of examples from the last section. So let's put our numbers in here. Get 2 minus 4, 1 and 3, 1 minus 3, 1 and 5, 3 minus 7, 2 and 12. Okay, so put all the coefficients of x, y, and z, all the numbers in front of x, y, and z specifically, and we have 3, 5, and 12 here specifically. No problem. Easy peasy. All right. Now, let's take a look at what we get once we reduce it down. So, let's go back to how you did the last problem, last couple of examples here. We're going to want to reduce this matrix down using the same steps as before. Nothing's going to change. All right, I want you to use those same steps here. And based on those same steps here, we're going to get a matrix here. So let's take a couple of minutes here. I want you to go ahead and find out what matrix you're going to get. Once you have a matrix on your calculator, just go ahead and type yes on the chat. Okay, and then I'll go ahead and reveal what matrix you should have gotten here through the process. So let's go ahead and take a couple minutes or so, and let's see what we find out. Okay, so once you have a matrix on your calculator that you're looking at, type yes in the chat once you're ready. Go ahead and put that in. All right, there we go. Sure, we got that. Okay, Chase got one. Good, good, good. Yes, yes, good. All right, I'll wait for more people to start coming in. Again, for some people, it could take a little time, which is okay. Chase, Drivers Planet, Morning, and Gerda. We're just waiting on a couple more people. Anna and Fidel. Anna. Okay, Anna says yes. Just waiting on Fidel and Hannah, just to be on the safe side. Always got to make extra sure. Where? Here it is. Anna, Fidel, did you get a resulting matrix there? Okay. Let's go ahead and throw that over. Just want to be sure everybody's kind of on the same page here. Well, maybe Hannah stepped away, so could be that Hannah stepped away. So just wait another 20 seconds or so, hopefully. Okay, looks like Hannah stepped away. Well, that's okay. All right, so let's go ahead and take a look at the resulting matrix that we got here. Okay, so I'm going to go ahead and go over this very carefully. So this is the resulting matrix that you should have got once you did all the steps again. Minus C, minus 0.5 or a half, depending on how new your calculator is. But it doesn't really matter, so. Okay, so this is the resulting matrix that you should have gotten here after reducing it down. Okay, you may see a negative a half, but again, like I said, it means the same thing. In any case, let's talk about what we want to see here on this particular part here. Impossible! That's incredible! So let's talk about let's talk about what we want to clue in on, okay? Because there is definitely something that we do want to clue in on, most definitely. So let's take a look at what that is. Wow, that is not what I wanted to do. Like, what am I doing here? I don't understand. The bottom equation is impossible. This is true. Yes, that is correct. So if we look here, let's go ahead and copy that down here because I'm not that great with Word, but I think still, as long as I get the point across, then it's okay. So all right. So here's our resulting matrix, okay, in its overall quality, which is terrible. All right, in any case, normally we would get X, Y, and Z here. So this says basically on the top, it says X minus 0.5Z equals 0. That's what it says on the top. Second equation says Y minus 0.5Z is equal to 0. Now the last part here is where we want to look at. This last part here, as Gerda has correctly pointed out, it's an impossible equation. This would normally where we would find our z here. Now, if you remember how it worked in the last chapter, we said if we got to a situation that looks like this would be 0z. 0z is equal to 1. And this is that situation we talked about in the last chapter, said, okay, if we had like 0y or 0x is equal to a number that's not 0, guess what? You get no solution, right? Because if we take 0 times any number, 0 times any number, as we know, is 0. So how could it ever equal 1 no matter what z that we choose? It's always going to equal 0 at the end of the day. So in this case, again, if you get this situation where you get the bottom row of the reduced matrix to look exactly like this, all right? So this is what you want to watch out for. So watch out for this part here. This is basically the crux in getting no solution, or again, a inconsistent system. Okay, so that's what we want to be looking at here. Now, another way to remember to express no solution here is, remember you have the circle here with the line through it, just like so. So again, just another notation there that represents no solution / inconsistent system, okay? Diabolical. Yes, math is always diabolical. How did you know my evil plans? There's too much evil. My evil plans, they'll expand. I promise you that. All right, any questions about that? Questiones. Nope, no questions? All right. All right, nope, perfect. All right, let's go ahead and take a look here at the next one here. You're convinced I practiced that laugh in the mirror? Maybe. You get that, when you become a math teacher, you're like, you get that little piece of power, and you're just like, you know, I can always turn to the dark side. Just take a little bit of the poison apple. Num 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 num. Just like, yes, this tastes wonderful, very wonderful. No one shall ever question me again. Exactly. They say I have a very evil laugh. I happen to not disagree with that. A wolf in sheep's clothing, that's right. I'm like the square root of -1, imaginary. Bam. You don't see you can't see me. Hit the music, everybody. Da, 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 da. His name is John Cena. Oh my gosh. All right, had to bust out the meme somehow. Okay. Alrighty. Let's look at this last example here. Or a sheep in wolf's clothing. Can I do it like SpongeBob SquarePants? No, my voice is too deep. Like, it's hard to do the SpongeBob voice because it's so high pitched. Oh, it's imaginary. It's in your imagination. I don't see. Well, I tried. You're right. I tried. Some things are easier for me than others. Let me tell you. To be fair, to be fair. All right. Let's go ahead and give this last part a try here. All right. How do we find dependent systems and matrices? All right. So, what are dependent systems? A dependent system is basically a fancy way of saying we get infinite solutions. Okay. Now, one thing that we're going to have to do here, we do have to be a little bit careful about how we express infinite solutions. So I do want to talk about that here in this particular case. So I'm going to go ahead and, which one do I want to do here? I do want to do one that's fairly specific. So, okay. That's okay. Sometimes it's just not going to work out. But that's all right. You tried, you had fun, and the journey was a little bit more important than the destination. So no problem. All right, so we're going to write in a new batch of equations. Let's go ahead and do that. So choose that. Yeah. All right. Go. All right. So in this case here, we have, okay, so we want to be very careful about this. So let's take a look at this very carefully here. We have 3 equations and 4 variables. So now the number of we don't have a square matrix here, okay? Because then there would be 4 equations, 4 variables. But we have 3 equations and 4 variables. So things are going to be a little significantly different than what we're normally used to, okay? This is evil. Yes. Yes. Yes, it is. Welcome. Welcome to your nightmare. Um, I like evil things. Okay. So let's go ahead and set up this matrix here very carefully, okay? Because we want to set this up in the calculator, and then we're going to see what this so um, I'm not even sure why anymore. It's kind of weird. Okay. Yeah, sorry about that. My connection drops randomly at times, so yeah, it's just kind of like it's kind of weird. As you know, I've had freezes and stuff, and I think it has stuff to do with my hardware. So uh so who's doing you dirty with being them up? Yeah, yeah, my Ethernet's doing me dirty. So I'm gonna see if the Wi-Fi will actually work a lot better with it. I don't know. If I got a Wi-Fi connection to the back of my computer, or just strip out the parts and strip out the motherboard and replace it with new parts and stuff. Computer is getting on in age, so um, it is kind of old. At least the motherboard part is, anyway. Uh, about 5 years old, 5, 6 years old. So could be one of those things. Anyway, I digress. What is important though is what we put in here for the matrix. Let's go ahead and do that. Okay, now in this case here we have 3 rows and we have 5 columns. So we have 3 rows and 5 columns here. Okay, so we're going to want to put all the 3 rows and 5 columns here. So when you set up your matrix in your calculator, it'll be a 3 by 5 matrix. Okay, let's put all the numbers down. 1 minus 1, 3, and minus 5, 10. 1 minus 2 minus 2, and 6. All right, perfect. All right, so this is our matrix here. Okay, Again, I want you to follow the same steps that we had from before. Okay, and once you have that, again, just type in. Did I get? Yeah, well, if that's what you got there, Chase, then just leave it as such. Okay. I'm going to type out what the answer is in just a second if that's what you got after doing the row reduce stuff. So for those of you who just got an answer on your calculator like Chase, go ahead and just type yes in the chat there, and then I'll show off the answer here just to see if it matches what Chase got or the like. So let's go ahead and do that right now. So Chase drivers and Fidel. Okay. Okay, Gerda, good. Planet, good. Okay, Morning and Anna. Yes, okay, good. Okay. Fidel, okay. Okay, Chase did, that's right. Anna, okay, good. Good, good, good. Okay, good stuff. All right, so it looks like everybody's okay. Okay, so it looks like unless I missed anybody here, yeah, drivers did. Okay, good. Somehow I thought I missed you there, but I didn't. Okay, so everybody did. That's good. That's good. So let's take a look at what the answer is supposed to be, and then we'll explore exactly what we're looking for here in a problem like this. So here we get 1, 0, 0, minus 1, and 3. So exactly what you got there, Chase. So that's right, 0, 1, 0, minus 5, and 5. Okay, and then 0, 0, 1, minus 3, and 4. So this is what we have here so far. Okay. Okay, so you should have that on your calculator after reducing stuff down. So if you have that, we're in really great shape. Okay, now what we want to do here specifically is to actually interpret this in terms of letters. Because we could say infinite solutions, but that's not exactly what it's going to ask you for your final answer here. It's actually going to want a set of quote unquote numbers. I say quote unquote here because they won't be actual numbers, but they'll be expressions here for all the variables. Now, if you take a look at how this is actually reduced down, okay, let's write down each one of them respectively here, okay, and we'll see how this works out. So the first one that you see there is you see x minus sorry, not x, pardon me, w minus x minus z equals 3. Okay, so that's what you have there first. W minus z is equal to 3. The next one here, you have x minus 5z is equal to 5. So x minus 5z is equal to 5. And then for the third row, you have y minus 3z is equal to 4. So we're just going ahead and just rewriting this back into its letter form. We do want to do that here in this case. Now you're probably saying, well, wait a second here. How do I know that this is infinite amount of solutions? Okay, well, a way we can go ahead and see that that's the case is if you notice here, W, X, and Y all contain Z here on the inside. So that means that we can express W, X, and Y in terms of Z. Okay, there we go. I think that'll work. All right, sorry about that again. Okay, so let's go ahead and try that again. Hopefully that didn't set us back too much. Okay, so all right, so we have, again, we can express W, X, and Y. So as I was saying here before that freeze here, we can express W, X, and Y here respectively in terms of Z. So let's say Z can be whatever it wants, okay? Z can be any number that you choose. That means that W, X, and Y are dependent on whatever we choose for Z. Hence why we get infinite amount of solutions since Z can be any number. So all we need to do here is just define it like so. We're just going to move everything that contains Z over to the other side. So what this means is that we get, for this first one, we get W is equal to 3 plus Z. Yes, yeah, it froze for me. So because my connection was being a dingus. So that's not on your end. All right. Hey, Stefano. All right. All right, here we get for x here, we get x here is equal to 5 plus 5z. Okay, so 5 plus 5z here is what we get here for the next one. And then finally, for the last one here we get y is equal to 4 plus 3z. Again, I'm just moving this z here to the other side, or this, I add 5z to the other side. So notice I've put w, x, and y here in terms of z. Are there any questions about that? About how I put w, x, and y here in terms of z? Okay, if there are no questions there, let's go ahead and get to the last part here. So the last part here is, how do we go ahead and express our answer? Because like I said, you do have to express your answer here in a very particular way. So again, we want to set this up as, like, say, a set of solutions here. So we have W, X, Y, and Z. So W here, as you can see up above, is going to be 3 plus Z, comma, 5 plus 5Z. So that'll be for X, comma, 4 plus 3Z, comma, and then finally, since Z can be anything it wants, we're just going to put that right at the end. So this right here would be your final answer for that problem. Are there any questions about that, about how we phrase that? No? Okay. So hopefully that made a lot more sense about why it's infinite solutions. But again, how we actually phrase the answer here is not just directly saying infinite solutions. We actually have to write out how we can acquire those, how we can express those infinite solutions. Again, it's dependent on one of those variables, so hence a dependent system. All right. If there are no more questions here, that's perfectly fine. That will end section 6.2. So we actually got through 2 sections here today. So that's really, really good. All right, we're in really good shape here. No problemo. All right, so that will take care of it for today, everybody. All right. So that'll take care of it for today, everybody. I want to thank everybody here for coming on out to the stream here once again. Hopefully you guys got a good look at matrices. We're going to be continuing on doing some more matrices here for Tuesday. In the meantime, the homework is still open, so go ahead and give that a go. I'm going to have to make up some, I have to make up a couple tests here tonight, so I got some extra work I got to do. But yeah, we'll be talking about the test here only after we finish Chapter 6. So that's what's on the agenda here first, is finishing up Chapter 6, and then we'll go ahead and proceed forward there with Chapter 7. I'm probably, like, I might have mentioned this before, but I may just end up cutting Chapter 8 altogether. So that's probably what's going to happen here. If I haven't mentioned that before, I'll probably mention it now again. So once we cross that bridge, I'll probably go down that route. Probably, I'm pretty heavily leaning toward going down that route of just cutting Chapter 8 out altogether. So, all right. All right. Thank you guys so much here for coming out here today. All right. Everyone, have yourself a very wonderful, healthy and safe weekend. The entirety of Chapter 8. I'm going to probably cut out entirety of Chapter 8. There's only like a couple sections in Chapter 8, Chase, but yeah, I'm probably just not going to do it. So it's like 8.1 and 8.5. There's the only 2 sections in Chapter 8, but I'm probably not going to do it just for time's sake. So I have other plans that I want to enact, so it's a little bit more important. All right. Thank you guys so much. Have yourself a very safe and wonderful night. Again, if you want to sign up for the chess club there at ECC, please go ahead. Please go ahead and sign up. You can contact Chase if you'd like to join the chess club there. It's not life-threatening. No, it's not. It's not life-threatening to skip out on those. It's I just feel I'd rather spend more time on Chapter 7. So, there's much more important stuff in Chapter 7 than Chapter 8 anyway. So, okay. Take care. Have a great night, everybody. And we will see you later. All right? We'll see you on Tuesday, everybody. Take care of yourselves. Have a nice, relaxing night and weekend. All right? You know where to contact me. Have a great one, everybody. We'll see ya. All right.